Our final plenary presentation this morning is titled Critical Factors for Commissioning and Startup Success. Research Team 312 focuses on best practices for commissioning and startup, identifying 16 critical success factors. Here with us to share the highlights of the research and to discuss how it relates to previous CII research on the topic is Joel Tremblay from Project Resources Company, a division of Chevron.
All right, thank you very much. And on behalf of RT 312, we're excited to be here at the 2015 Annual Conference and have some exciting findings to share with you today. But before I get started, I want to take this time to thank my fellow team members who over the past 2 years have managed to pull together this final product, Critical Success Factors for Commissioning and Startup. The team was comprised of 18 industry members and 3 university researchers, representing over 450 total years of industry experience and 572 projects commissioned and or started up.
Schluck Commissioning Disaster at 10. Watch us on WCSU.
Wow, look at that. What a coincidence. Here we are talking about commissioning and startup, and looks like we have another failure story to tune into. So we'll look to that a little bit later. Has anyone here experienced failures during commissioning? Okay. Through a variety of literature reviews, we found overwhelming evidence to support a case for action. I mean, if you look at here, folks, almost half of facilities with significant operability problems, 6% cost growth, 9% schedule growth, overruns occurring in 40% of all projects due to commissioning. In addition to this, there has been no CII research update in over a decade on CSU. And with industry ever changing, project complexities increasing, and technologies ever expanding, it was time for CII to readdress the issue of commissioning and startup. The purpose of our research was to better understand effective management approaches and new technologies in order to more effectively achieve successful CSU of capital projects. Some of our specific objectives of the research included the following: broaden the understanding of key terms pertaining to commissioning, startup, and initial operations. Second, identify critical success factors, which we refer to as CSFs, and can offer a stepwise advancement in planning and execution of CSU. Third, assess the CSF impact on commissioning performance. Fourth, show how the CSFs link to the existing Planning for Startup Implementation resource, CII Publication 121-2. Fifth, analyze project CSU failures, specifically where there was failed links to CSFs. And then finally, identify new innovative technologies that can help further leverage CSU performance. Our research focused on commissioning and startup and the applicable activities across all project phases, so from project initiation through initial startup. Our findings are focused heavily on industrial facilities, such as petrochemical, power, water, wastewater treatment, and nuclear plants. However, we believe that most of their findings are applicable to building and infrastructure projects, such as pharmaceutical, hospital, institutional, and airport projects. Out-of-scope items included steady-state plant operations, so issues that occur after final performance testing, and then a comprehensive rewrite or update to CII 121-2. Our team applied a rigorous methodology to arrive at its findings, and it's illustrated here. The establishment of the 16 critical success factors, or CSFs, represented the cornerstone of our research findings. Once the CSFs were determined, a number of subsequent CSF-related developments followed. Some of those developments include timing of CSF implementation, identification of CSF indicators or telltales of achievement, 4 detailed commissioning failure mini case studies that highlighted failed links to CSFs, a CSF indicator checklist tool, and then finally, identification of innovative technologies to support or enhance CSF implementation. The 16 CSFs were established by starting with 139 potential factors through expert professional input from 40 CSU experts, objective data collection, and data analysis with statistically significant results, those 139 potential factors affecting project CSU efforts were refined down to just 16 critical success factors. These CSFs are identified not only by their specific required actions, but also the project phase sequence, proving there's a need for generally earlier planning for CSU. The effectiveness and impact of the critical success factors is partly driven by timing, so it's very important to understand the optimal or appropriate timing of implementation for each of the 16 factors. So we mapped the 16 CSFs across the project phases shown here. Not surprisingly, we found that 13 of the 16, or 81%, are initiated prior to start of construction, with 9 of the 13 completed prior to construction start. The key message here is don't delay in implementing the critical success factors. Our findings clearly show a paradigm shift is needed in the world of project management. Project managers need to understand the impact to overall project performance if commissioning teams are not put in place early in the project life cycle. The short-term cost savings associated with a smaller project planning team is far outweighed by the impacts to production attainment, project cost, and schedule. So to give you a flavor of some of the critical success factors identified, I'm going to highlight a few. The first shown here was CSF number 4, early alignment. Early alignment between engineering, construction, commissioning, and operations is key. For example, how a facility will be started up is important to be asked during the design phase of the project with key people involved. Questions like, how is this facility going to be started, need to be asked and studied and to see if the design can support initial startup. Project managers need to set this expectation. The second being CSF number 13, integrated construction commissioning schedule, or a fully integrated schedule. It's critical to achieving CSU objectives. The schedule needs to be detailed enough to drive completions at a tag or a component level. The schedule also facilitates the transition from area-based completions to system-based. Our implementation session is going to cover the remaining 14 CSFs in more detail. Through both survey and analysis of actual project data, we identified 6 CSFs that were less frequently implemented. 3 examples are shown here. Value recognition, system engineering and feed, and system focus continued through detailed design. The less frequently implemented CSFs represent key commissioning planning activities. Failure to implement these CSFs greatly increase the risk of poor overall project performance. For example, for these 3 CSFs that you see here, 65% of our underperforming projects did not accomplish these CSFs. So how do we know these 16 CSFs are truly valid? And how do we know they truly impact commissioning and startup? So the research team pursued answers to these questions by analyzing real project CSU performance and associated CSF implementation. The graph that you see here displays commissioning performance on the y-axis versus CSF implementation on the x-axis, normalized. A survey of CSU managers was used to collect the data. For the commissioning and startup performance data, the team employed the assessment model that's recommended in the CII publication 121-2, Planning for Startup, which measures each of the 8 commissioning startup criteria on a 5-point scale for a maximum of 40 points. For the CSF implementation assessments, the team developed 25 indicators of achievement questions worded to elicit simple yes or no responses. What we found was the statistically significant relationship that indicates that more than half the variation in project commissioning performance can be explained by the critical success factors. So let me repeat that. More than half of the variation can be explained by the 16 CSFs. Another key finding from our research was the identification and characterization of 5 innovative commissioning technologies. Here you can see them mapped over the relevant project phases. Each of these technologies significantly leverage the effectiveness of CSU teams and their efforts. An example of one of these is simulation-based virtual commissioning and operator training, which helps projects realize cost savings through shortened operator training and reduced startup time. Our implementation session is going to cover 5 ICTs in more detail. Another key finding from our research was the determination of the linkages between the 16 CSFs and the RT 121-2 Planning for Startup resource. This served as an effective cross-check of the CSF with regards to frame of reference and industry relevance. All 16 CSFs were mapped to the existing Planning for Startup model. Here you can see an example of that, where the CSF linkages for Phase 2 concept development and Phase 3 front-end engineering are shown. Some of our other research findings included CSU terminology, milestones, and organizational functions, CSF indicators of achievement, barriers to less frequently implemented CSFs, learnings from 4 mini case studies, and then links between CSFs, quality, and safety. We have packaged all these findings in a 2-volume implementation resource, Volume 1 summarizing the RT 312 findings, and then Volume 2 summarizing the 4 mini failure case studies. These are both available for download right now on your mobile device from the CII AC app.
Commissioning problems at Schlock worse than originally thought. Catch us after the game.
So yeah, that reminds me. Please come to our implementation session, where you're going to hear more on this shocking, or should I say schlocking, commissioning disaster story that is developing at Schlock Asbestos Manufacturing. The WCSU news team, anchored by Dale Millsap, supported by Inquisit reporter Liz Shaw, and Matt Sickstrom will be covering the story live, including interviews from Schlock Manufacturing Commissioning Manager Mauricio Rodriguez, RT 312 research team members Tom Peary and Brian Nordman, and as well as RT 312 principal investigator Dr. Jim O'Connor. You can join us right here in this grand ballroom at 11 and 1 o'clock. In addition to that live coverage of this disaster story, you're going to be introduced to our CSF implementation checklist tool. So thank you all for your time today, and the team, RT 312 team, looks forward to seeing you at our implementation session. Thank you very much.